Hi everyone, I am Dibyendu Gonai and you are watching Math Cyberspace. So today's theorem is from Neighbourhood, and the statement of the theorem is a set S is a neighborhood. The set S is a neighborhood of X if and only if there exists a positive integer n such that, let me show you, such that x minus 1 by n, x plus 1 by n is a subset of S. So before proving this theorem, let's understand what the statement is saying. So suppose this, okay, this is our real axis minus infinity to plus infinity. And there is a point x. Suppose this is the point x. And there is a subset. This is the subset of x, subset of R, real number. Okay, so S, this is subset of R. Now the statement is saying that there will exist an open interval or a subset x minus 1 by n, x plus 1 by n. Suppose this is x minus 1 by n, x plus 1 by n. For there exists a positive integer n such that this will be, that means x minus 1 by n, x plus 1 by n, this will be subset of S. We have to prove it. If this is subset, then S, that will be a neighborhood. That means it is nothing but this is the statement of neighborhood, and I have to prove the statement of neighborhood. Okay, so let's prove it. Proof. Here S is a neighborhood of X. Okay, so since S is a neighborhood of X, so there exists an epsilon greater than 0 such that there exists an open interval x minus epsilon, x plus epsilon, that will be subset of S by the definition of neighborhood. Okay, so x minus epsilon, x plus epsilon, this open interval is a subset of S. Now since epsilon greater than 0 and this epsilon must be a real number, so 1 by epsilon, that will be again greater than 0, and 1 by epsilon, obviously this is from real number. And we know that by Archimedean property, the statement of Archimedean property is that for every real number, you can find out a natural number which will be greater than the real number. Okay, so here 1 by epsilon, this is our real number. So we have a natural number n belongs to set of natural number. That will be by Archimedean property, that will be n greater than 1 by epsilon, right? So if n greater than 1 by epsilon, so from here what we can write? We can write 1 by n, that will be less than epsilon, right? And minus 1 by n, that will be greater than minus epsilon. Now, why I have done this step? Because I have to show that x minus 1 by n, x plus 1 by n, this is a subset of S. That's why 1 by n is less than epsilon, minus 1 by n greater than minus epsilon. I have done this step. Now what I am doing? I am adding x in both sides. So x plus 1 by n, that will be less than x plus epsilon, right? And x minus 1 by n, that will be greater than x minus epsilon. If I draw this in a graph, let me change the color. If I draw this, suppose this is, and here is the point x. Okay, and suppose this point, this is our x minus epsilon, this is our x plus epsilon, and here it is saying that x plus 1 by n, this is less than x plus epsilon. So this is our x plus epsilon. So x plus 1 by n. This is our x plus 1 by n, right? And x minus 1 by n, this is greater than x minus epsilon. Suppose there will be in this position x minus 1 by n. So from this figure, what we can say? We can say that the set x minus 1 by n, x plus 1 by n, that means x minus 1 by n, x plus 1 by n, this interval, this is subset of x minus epsilon, x plus epsilon, right? And from here we see that x minus epsilon, x plus epsilon, this is subset of S. Okay, so what we are getting? We are getting that x minus 1 by n, x plus 1 by n, this is subset of S. So our first part is proved. I have started from here. I have considered that S is a neighborhood. Since S is neighborhood, so we will get an open interval x minus epsilon, x plus epsilon, that will be subset of S. And from here, I have proved that x minus 1 by n, x plus 1 by n, this is the subset of S. Since the statement is if and only if statement, so I have to prove the converse part also. So converse. Conversely, in converse part, I am taking that x minus 1 by n, x plus 1 by n, this is subset of S. And in this interval, x exists, so x belongs to x minus 1 by n, x plus 1 by n, and this is subset of S. And this is nothing but the definition of neighborhood, or you call the mathematical representation of the definition of neighborhood. So if x belongs to this open interval and this open interval is a subset of a set, then the set will be a neighborhood of the point x. Okay, and this is our converse part. The set S is a neighborhood of x. I have to show that. Okay, so I have proved it that this is the neighborhood of x. Okay, I think it will help you and it will be interested to you. Thank you.